Okay, good evening to all. Thanks for joining. Uh, Before others join, I think we have few people who have texted they will join in another 5-10 minutes. Uh, what you do is I'm going to share an MCQ which I shared last week, and these questions MCQs are from the discussions we had in last two sessions. I am very hopeful most of you can answer 80% of the questions. Okay, there will be 10 MCQs. I know you can answer them because we discussed in the last two sessions, maybe whether you have revised the notes or heard to the recordings. But I want you to attempt this in the chat. Okay, let me know how far you understood, because the next step is we'll be going with some classical examples of implementation of these ML models, okay, in various scenarios, and what are the regulations we need to follow. Okay, step by step we'll go, try to understand each model. Then we will work live with some of the platforms. I said could be ML Azure or AWS, Amazon, or ML Lab, OpenML Lab, or Google Colab. I'll tell you which one we can work. Uh, of course, the best is ML Azure, Microsoft Azure. That will you need to register into that. That is more, private and confidential, unlike other platforms which are very open, because other platforms already have the trained models. So in our workshop or in our works, what will we do is we start from training. Okay, we'll have the raw data. We'll have the raw data and we'll start from training the models, and let's see how it comes. But before that, I want you to, I mean, it's not for you, it's basically for me to understand how you got these different ML models, okay, more to be digested or to be in a stage to implement them, or still you need to understand this, okay, in the larger context. Oh, please go through this, and I request everybody, including Priyanka, to attempt, though you are not there. I hope you have to listen to the recorded lectures which I have shared. If you are not listen, also please share. Please attempt this.
Okay.
Okay, these are 10, mainly regarding the ML models which we have discussed. Okay, it's like which model can be most probably used, okay, for which of the activities in QARA. And I mean, in the last session also, I told there could be multiple answers, but you need to choose the best. And when you have two, three answers, you can always discuss and debate with me, which could be the right. And I also told you it's very difficult to explain in AML what is the right answer. Okay, it's not problem with me or with you. It's problem with the subject of AML, that you need to have a lot of explainability, like what is right. Say there could be on logistic regression. I can use, it depends upon you which you want to generate documents. that may maybe not the right, detect image effects or estimate probability of events or design medical devices. Some are absolutely wrong, but some may be very close to what is right. So you can start uh, maybe in next 7 8 minutes complete this, because we'll be going into a real conceptual thing of how to work on these models once we have the data in. Yeah, Pranita, I really appreciate you. So, do you need time to answer or should we proceed? Actually, Pranita answered everything right. 10 out of 10, she answered right. Maybe you can check her chat and know the answers. Arulmati also did well. By default, most answers are either B or C. So you can rule out A and B. Yeah, Kirti is also good. Yeah, Kirti, you're done 100% right. So, what is left? Arulmati, Pranita. Of course, Priyanka was not there, I understand. For most of the sessions, is not there. But however, no, I said either you choose B or C in any of those, you can answer it. 50% of the times you will be right if you answer B or C. Yeah, these are very simple. Simple questions like so. Priyanka, should I wait or shall we move ahead?
We'll move ahead, sir.
Okay, fine. But I request like you go ahead. I mean, you go through the recorded lectures because that's maybe last two recorded lectures. Uh, the two are very important to understand what are the models and probably what's the concept in them. And bit on like on application we haven't discussed much, but it's good most of you have attempted that, right? Okay, but today we'll be discussing on all applications of all the models. Okay, we have some 7 to 8 models. Step by step, we'll pick up an example. Okay, step by step, we'll see how to work on these models. Okay, what the inputs will be, what the outputs will be, how we need to, analyze the outputs, what are the limitations of them, where you can't use some of the models, and what auditors basically ask. Okay, if you have time, I will also tell you what are the regulatory compliances, like whether in MDR or in USFDA or in ISO, how we are complying with the regulations to use AML. I think somebody, Susmita or somebody asked me in the group, like, what is the regulatory compliance? I know that's very important. Without regulatory compliance, we can't use them in our systems, uh, in our activities. Absolutely, there is regulatory compliance. I'll tell you how to write that regulatory compliance and SOP on how you train the data. Train the model, how you validate the model, what the outputs speak of. Okay, what is the context we are using them? Okay, and what are the limitations? And what are the limitations and what is the need for revalidations or retraining the models? What we call like models have drifts over a time, they drift. I tell you why there will be drifts. There will be hallucinations. Okay, there will be black boxes. Okay, hallucinations, black boxes, like uh, there will be drifts. I told you there will be a lot of problems with models where you need to keep them. Okay, what we call, we should have governance over the models. Okay, every time you need the input data, what you are providing, to be very apt. Okay, consider all variables, and simply I say that your trained data should not be different from your test data. Okay, when I say when you train some data with lot of variables, your test data should also have the same variables. Okay, if the variables are not same, okay, then there will be a drift where the precision and accuracy of the models will go wrong. What I mean to say is, for example, like if we are trained data, maybe let's take the clinical scenario. If your trained data is of controlled clinical trials, okay, some prospective controlled clinical trials, you have trained your model based on that data. I think you know what I mean by controlled clinical trials. You have some selectivity, like you have an exclusion criteria, you have inclusion criteria, okay, and also you have something like uh, some considerations where you need to take, okay, on the criteria of your l- power of the study, level of significance, okay, which are basic statistics or p-value or confidence intervals. But mainly when you use a controlled clinical data for your training of the models, okay, but your text data is in real world data. In real world evidence or real world data, you don't have inclusion and exclusion criteria. Okay, when you give the real world data as your test data and ask it to do some predictions or calculations, okay, it will go wrong. So it should be a similar data, more randomized in all variables. So if you have a controlled clinical data, then I mean, never use a controlled clinical data, better to have a real world data to train the models. I mean, that is the order of the day. All models should be trained on real world data, not on a set of data where there will be a lot of missing data or missing variables. Then suddenly you give to the model the test data with new variables, okay, or new characteristics. It will go wrong. What we call that as drifting of the data. Okay, I told you hallucinations. Hallucinations are more because it models have a memory. They memorize something, mainly the deep learning models like the LLMs, which we discussed last time. They have a memory. Okay, though you ask a different thing, still they will give an answer which is more relevant to your past questions. Okay, LLMs are very, I mean, you need to have very controlled governance on LLMs when you use in medical devices. Okay, mainly I said LLMs are used in a lot of activities. LLM is a deep learning model, large language models. NLP is basically we use NLP on PMC, on complaint handling, all that stuff, which I will tell. But LLMs are used in very vast, like on clinical evaluation, clinical literature search, and all that stuff. Uh, the point is like they keep continuously generating data. Okay, they can sense what we will be asking next, and they provide it in options. So you need to be very careful. We discussed what is LLM. That's more a deep learning. So I'm removing this. I'll share one more slide. This is a problem with when you have a AI agent, you'll face this problem. That's what I'm going to discuss on AI agents and agentic AI. Then we'll move to the classical examples of how all these models are used in medical devices. Okay. Okay. I'll go through this very quickly uh, because if I miss this, I'm say a year back, even I was of an opinion that deep learning is the end of artificial intelligence, or deep learning in the sense with LLMs like or the random forest, decision trees. Okay, I thought that will be the end of what we can use in the AIML. Okay, but a year back, just perhaps in last 1 year, we have come with another set of new models, okay, that are called AI agents. One is AI agents, the other is agentic AI. Okay, of course, these were used in other domains for a lot of autonomous works, but haven't used in medical device field. Okay, the AI agents and the agentic AI. But I'm pretty sure, like in next 1 year, because of, as you see the advancements that are happening in AI/ML, in next 1 year, you see these AI agents or agentic AI also being used, okay, in the medical devices, basically in the QARA. Of course, now in some sections of QARA, okay, I'll tell you on regulatory intelligence or on the clinicals, still we use AI agents or agentic AI, but the regulatory compliance is at high risk. Okay, we need to do a lot of validation. We need to do a lot of explainability to the auditors. But again, I repeat, there is high probability that these two, which are now um, currently, which are now the latest AI models or AML models, that is agentic AI. Sorry, I have some bad throat since yesterday. Agentic AI agents will be the forefront, and I'll tell you the reason how they can dominate a lot of our work. Okay, and chances that they may replace some of the, I mean, this is what Madhusri was not there. She was asking how AI agent can replace humans. Okay, because AI agents learn, AI agents or agentic agents learn how to work autonomously without human in loop or without human intelligence. Okay, I mean that's where that is the main issue now. How AI agents or agentic AI can work autonomously in also in some of our activities, some of our fields in medical device domain, but it's risky. But I don't know in next 1 year, would they be controlling the QMS system or the regulatory system with their decisions? Okay. Their decisions in the sense it's not that they take decisions because we have trained them in such a fashion that they can do a lot of tasks based on the objectives we what we provide. They can do a lot of tasks by themselves. Okay, they can also do goals oriented work. Okay, you give some objective, they can achieve it. You give some goals, they retrain themselves. Okay, uh, retrain and they, I mean, it looks interesting. Like some 10 years back, okay, 10 years back, where we had one movie which started creating its own replica or its own phenotypes, okay, of Rajnikant. I forgot the name of the movie. I mean, it becomes autonomous. Like it's very risky, and I mean that's a problem now. Everybody is talking. Even the big AI companies are talking. Whoever you pick up, they are talking on AI replacing human jobs or human work when they become autonomous. Or is still risky to have autonomous AIs, AML systems. Okay, in some domains. Yeah, maybe you know the movie. There are a lot of movies. Like you have a sequel of movies that came. I think it's Robo One and Robo Two came. Robo One and Two. So, but very good movie that time. But now it looks really it's something is happening. What I mean, I know the director Shankar is a very good director. How he has visualized that robots can become autonomous. See, AML is nothing but you create an humanoid robot. It uses all these models. That is humanoid robot. It takes the shape of the human. We call it as a humanoid robot, or you can call it spobot. There are different names for that. Uh, People started giving different names. But once they start thinking of themselves and become autonomous, okay, then what is the use of human intelligence? That's what we'll be discussing on AI agents and agentic AI. Agentic AI is, I mean, like it's very serious. Okay, AI agents we can control them, but AI agents once you deploy them in your system, they go so autonomous, like it's not they use the intelligence, but they use their intelligence based on certain patterns or whatever we discussed on the ML models. They all the ML models are integrated, okay, into a particular system. where it can use any model, okay, where it can take from simple linear regression to the deep learning or convoluted or LLM. It can use any model, CV or NLP, and take decisions, autonomous decisions. And it could say this is a complaint, this is not a complaint, and it start writing the root cause analysis we discussed the other day. Okay, it only writes the COPPA, and it only submits to the regulatory body. Okay, without human loop or human intelligence, it classifies them as complaint, which complaint it is. It does the root cause. Okay, writes the COPPA. It only does the verification of effectiveness of the COPPA, and it can only submit through the database or the link, whether it's Moodle or Udemy. Okay, how you have worked on the complaint, and the more risk in this autonomous and AI agencies, when they do the classification of adverse events, like it could be serious adverse event or an adverse event or an event or a normal, it may not be a complaint or an event, a serious. But when it classifies them, it takes a decision based on the report it has. And when it submits to the regulatory body autonomously, okay, mainly people who are working in medical equipment, it could be a maintenance issue, or it could be a diagnostic equipment which has an issue, okay, problem, maybe it give a false negative results or some wrong results, okay. uh, or in medical devices, something maybe a failed FSC, a field safety corrective action. When it starts reporting without human intelligence, that's what I said. We need to have a hybrid intelligence, both AI and HI. But when you have these agents, of course, I deployed one agent. It basically replies, doesn't do much, but it replies to the emails which are more conversant, replies to some WhatsApp, or give some information on the updates that are happening in regulatory or the quality, when I link them to lot of websites. Okay, but I'll just run through this. But guys, think that this AI agents or agentic AI are going to become very, very prominent and important, okay, in next 1 year. Though as of now, some domains are using, but I'm bit spectacle on how they can intrude into the medical device domain. Okay, I'll tell you later, like why people are afraid of this. Okay, between the skilled, semi-skilled, and unskilled. Okay, some we call white collar jobs. Uh, Semi-skilled, you have unskilled. Unskilled, because of automation of AI, some jobs you can lose. Okay, in the unskilled. But when you are skilled, there is very little chance that it can replace, because I mean at end of the day human decisions matter. But there are some incidences where autonomous AI have taken better decisions than human decisions. So there are some case studies which I have read, like mainly in I think I told to you, in medical diagnostics. Okay, medical equipment used in diagnosis of diseases. This ML models are they take ML models take a better decision, or better, we say better diagnosis, does better diagnosis and interpretation than the humans, or what we call the ground truth from the physicians. But still, I mean, the physician has to approve it, sign it. I think I told you example of on a cancer detection. AI models does a better interpretation of the cancer in early stages than what our oncologists will do. All forms of cancers. Okay. And also in prediction of lot of diseases. Okay. Of course, I'm developing an app on that. How you can predict cancers, how you can predict cardiovascular risk, and also on the basically on genetic risk, on old age disease like Alzheimer's and dementia. So after LLM, okay, we discussed about NLP, CV, okay, object detection, I mean a lot of things, linear regression, logistic regression, okay, forest, deforest, convoluted network, all of them, okay, are deep learning, except those supervised, unsupervised, what we have discussed, unsupervised or without labels. So all this come under deep learning only, including NLP is very simple. Okay, natural language processing. LLM is perhaps the best, what we call the deep learning model, because it does a lot of work. I mean, it can generate any number of text or any number of reports. It can answer to anything. Okay, because it stores tons and tons of data. Okay, and that's what we call generative AI. What is like ChatGPT or Grok or Llama or something, Perplexity. This all works through large language models. Okay. And after large language models, what came out is, I mean, last 1 year, is the AI agents. Okay. But I'm talking in context of our QARA, but I'll give you some inference to other domains also, like what they will be doing. Because when you look at the other domains, they have a lot of utility compared to the medical device QARA. But still, in some of our field also it is used, that also we look at. Okay, what AI agents will do? Okay. First thing is they perceive information from its environment. Okay, like think of an robotic AI or an AI agent. It environment in the sense the data what we provide. It perceives the information and it decides what action to take. After you give the information, based on the information and the context on which you have provided the information, it will decide like what I should do with this, what action should I do with the information. Okay. And it acts on the decision. It takes a decision that, okay, I have the data, I have taken the information. Information could be in any form. It could be text, it could be objects, it could be images, it could be numericals, anything. It perceives the information. So it's such a complex model, complex deep learning model. It can perceive anything. Okay, like the other models we say some only take images, they convert them into pixels, the pixels get converted into numericals. But in large language or NLP, we thought words were taken, they are tokenized. Okay, and each token of words they rephrase. Okay, there will be pre-processing that happens and it keeps uh, taking the decisions on that. Okay, and they observe the outcome. Okay, they know what is the outcome of that data information that we have given. Okay, it takes action on it, it acts on it, it takes decision. Okay, after the decision, you'll get some outcomes out of that a decision or action, and it repeats this cycle autonomously. Suppose if you give some other information, okay, second time or third time or fourth time, some information, Okay, it autonomously does this. So what we are doing, what we are understanding in the context when I say it may replace humans in certain jobs is, once you train this model in a particular pattern, okay, I'm giving this information, okay, you perceive this information, you act on that, take some action, take some decision, okay, you see the outcomes. What are the outcomes? Okay, based on that outcomes, you learn it. You learn what are the patterns, how the outcomes could be. Then when second time I give something like some more information relevant to that. Okay, it's like you are combining lot of ML models together. Okay, maybe when it is a text, it may take up NLP or LLM. Then if it needs to take a decision, it may adopt decision trees or random forest. Okay, then you need to, if it is an object, it may take an image or an object, it may look into, it may work through CV or computer vision or object detection. Okay, if it is some data on classification or probability, it may pick up logistic regression. But it takes a decision through a deep learning. It could be convoluted neuronal networks, or there are a lot of deep learning things. What we discussed on random forests or convoluted decision trees and convoluted neural network are very basic models. Still, there are more advanced models in deep learning which can take decisions. Once it takes decisions, it has an outcome. Okay, based on the outcome, it learns, it trains itself. Earlier models we said like once we train, it is enough. But in this AI agents, it itself retrains. Okay, there is no need of training it every time. Other models, I said, we need to train them over a periodic time, because if you don't have the relevant trained data or input data, there may be drifts. The results may go wrong, or the test results may go wrong. Whatever the test inputs, it may go wrong. But here, what happens is that AI agents, they retrain themselves based on the outcomes. Okay, they will be more advanced. You can look them like the human system working. When you train somebody, some human like this, okay, this is the information. You need to take decisions on this. You work out on this document. Okay, what are the actionable items? What are the objectives? Okay, you take a decision and give me what are the outcomes of this. And we keep training the people, so that at some point after 2 3 times of training they become autonomous. So there is no need for an head or a department head or somebody for that particular guy, okay, to be monitored every time. After some time he becomes autonomous. He takes the decision, he takes the calls. Similarly, the agents also does the same. You keep them doing this task 3 4 times, and at certain point they become autonomous. So the person in that particular chair, okay, in that particular position may become irrelevant when agents take this autonomously. Of course, there are a lot of limitations which I'll tell you. See, an AI model produces an output like any other model, but an AI agent takes action. See, we have like in AI models, we'll get when you give some input of text data after training them, when you give our test data, okay, after training and validation of that model, once we give the test data, it will give the output. Okay, the input data of the test, it will give the output. But here AI agents is after giving the outcomes or the output, okay, what they do is they retrain themselves. Okay, the outcomes what it got, as I mentioned, once you get the outcomes here, it repeats the cycle autonomously. Okay, once you get the outputs, it takes actions. Okay, like should I go further? I'll quote some example like take action for this complaint on COPPA or report this to regulatory body or should I reject it, accept it? Okay. But in other models, we have seen there will be a human QARA decision that says that we need to fix the threshold, whether it's yes or no, accepted or not, what is the probabilities. Even in LLM, we have the human loop there to review what we are getting. Okay, even in object detection or in the uh, computer vision CV. Okay, this single distinction changes the entire regulatory risk profile. So when it becomes autonomous and it takes actions, okay, this is what differentiates other models, okay, from the AI agents or agentic AI. Agentic AI is still risky, okay, because it is taking actions on what the outputs you are providing. It's not the machine for, we have trained the machines to take decision, but that's what I mean, what we call advanced ML models or deep learning models. We move when we say LLM is the most advanced, there are other models coming, and I don't know what other still advanced models that may come in next 1 year or 2 years. But as of now, we have AI agents and agentic AI as the most advanced. So again, I told you as we go deep into the advanced models or deep learning models, okay, the complexity of the models increases, okay, the risk of the models increases, using the models increases in a particular activity, the explainability of the models becomes difficult. Okay, how we explain it? No, it will be very complex. Of course, they handle a lot of complex data, which we can't do. But how we can explain to somebody? Okay, we can explain it in a very superficial way. Okay, this is how it works. We'll tell the core principle, but there will be some underneath what we call pat underneath patterns, okay, which I'll tell you in some of the examples, which you can't see or understand how it is working. Okay, that's a problem with these complex models. See, why they exist is traditional models like the what we call logistic, supervised, unsupervised. They can analyze data, provide recommendation. They just stop there. The good, I mean, the agents, AI agents, why they came exist or why they uh, came in apart from availability of that models is they execute multi-step tasks. That's what I told. They can work together with lot of models. You give a deploy CV linked with computer vision, linked with NLP, link it with LLM, link it with some deep learning to take decisions, or any models you can use convoluted networks in between. Okay, you are linking a lot of models, multiple steps models for it to take some decisions. Or you can work, write new algorithms. Okay, like how you can loop autonomously, you go back and rework on the same thing so that there is no need for the humans. Okay, and they operate continuously where humans can't do it. Okay, adopt actions over time. They can change their actions also based on how the outcomes are. Okay, there could be little bit intelligent than humans based on the outcomes or the patterns of the outcomes. Okay, it may change it action or decision like, okay, the data is coming in such a fashion that there are too many complaints that are attributed to one category. Okay, or maybe you can, there are some examples like how you can stratify or do the risk classification. what we call risk severity or risk index. Okay, what is the probability of what are the occurrences of the complaints, what we call probability into severity. It gives you risk index, okay, or severity of risk or risk index. We'll see an example how it works. So it can take action like you have a particular complaint coming over with more likelihood, okay, severity may be high or low, it takes some actions on that. Like it may complain saying that these are more, okay, and hence it does. I mean, when I say it takes actions, because you have provided it options to take action. Sometimes it is good, but sometimes it may go wrong. Okay, reduce here. I mean, as I said, AI agents are okay until we have a human in loop or human interference or governance over it. But compared to other models, you have little intervention. Humans have very little intervention because these systems are taking control autonomously. See, the advantage one we can think is when I talk of A and HI, oh, as you know, time is very important. The richest person in this world, even Elon Musk can't buy time, okay, or Ambani can't buy time. Okay, but the point is you can use time very smartly. Available time for everybody, it's 24 hours. Okay, it's not for Modi, he has 28 hours or something like that. So what we need to do smartly is we need to utilize the time properly in a smart way. Okay, and we need to multiply the time. Whatever time is available, you need to multiply it through different options. So actually AI is one that gives us the option of doing bulk of the work, okay, which humans, okay, yeah, Madhusri has joined. Actually, I'm answering your question only.
Yes, sir. Good evening.
Yeah, good evening. Actually, when I'm in the sharing mode, I can't see who is there or who is not. That's why I keep speaking to myself. I want to see the screen also. Actually, this is the problem with Zoom. Of course, we can adjust this, but I don't feel so. Okay. Actually, I was talking, there will be very little bit human intervention. I don't know whether you listen to this, Madhu. I was talking on AI agents, how they can replace humans. Uh, I'll also tell how I told you like how white collar jobs can't be replaced by AI because we have something skilled. We need to categorize the employees as skilled, semi-skilled, and unskilled. Skilled are those we basically are white collar jobs. Okay, generally we call white collar jobs in government. In governments, we call them as bureaucrats. Okay, or bureaucrats at a higher level, like IAS, IPS officers, or something like that. In QARA, we call them department heads and all this. Okay, they have knowledge and they have experience, but I'm coming to AI agents as I said. Okay, the reduced human intervention. Yeah, this is what I am talking. When you have limited, when you have the same time like others, okay, 24 hours for any human, okay, living in this on this earth, how you can work better, smarter, and multiply your time. Okay, one way or one advantage that AML provides is this stance where you can utilize your time okay, properly, smartly, okay, invest a lot of money in the time in getting more time, like, okay. Traditionally, if you look, like, we were being just bombarded with a lot of documentation work, okay. We were there in all things, doing the documentation. But now, when you have more routine work, administrative work or routine work, which we do every day and writing the SOPs or clearing the, reading the PMS or something like on acceptance and rejections in QC, writing some reports, all this can be made autonomously, okay, where you can spare, you will have a lot of time to do other works where it requires human intelligence. Okay, let AI do its work where it is good. Okay, huge data, large data, it can do a lot of things. Okay, PMS we discussed in all the AI models, what it can do fast in 5 minutes, 10 minutes, where for us it takes almost 4 5 hours to do that. So let it do these bulk work, okay, the donkey's work, and we can do some more intelligent, human intelligent work, or where our intelligence can be used in other areas, okay, like on maybe on research or innovation, or some areas like still where we can improve the systems, okay, for better patient safety. You can think of it, you have time to think of, okay, in the same domain. I'm not telling to move away from this domain of medical device or QARA. In the same domain, what other things can be done, better things can be done. That gives you ample time than just scrolling or writing records manually or taking working on documentation and this SOPs. It does autonomously. I'll quote some examples, like what are the things AI agent can do autonomously without human intervention, which are of very less risk. Okay, if it goes wrong also with that AI agent, it may have risk but very low, and it will have, I mean, apt or okay, like regulatory compliance. Again, regulatory compliance, something which it comes to the individual, the task what we are assigning, okay, and how better you can explain it. Explainability, when you share the data to the public domain, or when you publish the data, or when you share the data to the regulatory bodies, that's where explainability and more of justification comes in. And as I told, maybe this session or next session, I'll tell you long how to give this justification explainability based on the regulations what we already have. I'm not creating new regulations. It's based on the USFDA regulations, based on the UMDR regulations. It's based on the EU AI Act. It's based on USFDA Act. Okay, there are some MDCG documents that are released for regulatory compliance, mainly in SOMED, but that can be linked. Most of the SOMED are linked to AIML. Okay, like, so you guys are there, Kirti and Madhu, like your devices are mostly linked with. They are not just SOMED, but they are also linked with machine learning, and IoT. Okay, just for you to compare, like we thought these are very traditional model. I don't say traditional, still we are using them in our domain. Okay, all these ML models, please remember them, like linear regression, logistic, supervised learning, unsupervised learning, uh, CV, object detection, NLP, uh, random forest, convoluted networks, uh, Okay, there are some more. Okay, and you compared with the most advanced, I mean, couple of years back, LLM is the most advanced, that is the generative AI. Okay, now we have, last year we have come out with still more advanced version of LLM, that is AI agent which can do your tasks without with little human intervention. It can complete lot of work or tasks. It can take actions. It can train itself. Okay. It can, of course, I don't think it will create another robot like how City does in Robo. Okay. It it can't create another human being, I mean, another AI like that, or humanoid robot. And I see a lot of risk, or I see a lot of relevance of that movie with what's happening now. Uh, I mean, only difference between AI and human intelligence, I feel, is the emotion, the empathy, okay, or what we call the sensitivity of feeling for a lot of things. I think that is only the difference which AI doesn't have. But if you train them on that also, that will be very dangerous. Okay. But I don't know like how it happened. So when you look at the other models which we discussed and look at LLM we discussed last session, and today we are discussing AI agent. Okay, they all can analyze the data. Okay, ML can't generate text. Okay, I said ML models work basically on numericals, or they convert the text to numericals, or they convert uh, anything like oh, what I said, like any images are there, they can convert into pixels. Okay, based on the pixels, they can work. I'll tell you a good example of computer vision, which is used for not computer vision, object detection, which is used for uh, QC tests for rejection and acceptance. Uh, so these all models cannot generate text, but LLM and an LLM can generate text. Like NLP can do the tokenization of the words, prefacing of the words, but it can't generate lot of text. LLM can generate, okay, large text, large phrases, okay. I mean, they can provide multiple information on different aspects. And agent also can do that, okay. It can generate text like LLM. So this is linked with LLMs. ML other models may not take decisions until you provide them to take decisions. Okay, limited in the sense I fix the threshold of that particular model. Say if it is above 0.5, accept. Okay, if it is less than, just 1 second, I'll close my WhatsApp. Okay. It is limited, but here in LLM and you can have some human loop, whether you can instruct whether take decision or not take decision. It's up to human intelligence. But in here, AI agent, still it is human intelligence, but if you have taken if you have given it the option of taking decisions, okay, it becomes so autonomous. So it's very much possible in AI agent because the algorithm is made so that it can take decisions. Either decisions it could take through the deep learning processes like again I'm repeating the random forest or decision trees or CNN, a lot of things. This can't take actions. The models what we think, and even LLM also can't take actions, but it can take action like what to do next. Okay, this can't operate ML previous ML models which we discussed, or even LLM can't operate autonomously. But LLM, actually I made it work autonomously. I don't know like how it happened, because in LLM, in one of the LLM generative AI, I have given a text, or I have given a command or a prompt to provide me news, the latest top headlines every day at 8 o'clock. And it provided for almost 1 month. Okay, in LLM model only. I made it autonomous. At 8 o'clock, it will give you what are the top 10 headlines in the global, or if you want India, or you want top 10 headlines in Hyderabad, it can give at 8 o'clock, but it's giving all stupid news. I stopped it. Okay, but again, we need to specify in the prompt like what news you want. You want a political, or you want from movies, or on sports, or XYZ. Okay, or more on kidnaps and killings and suicides. It will be. Partly you can make, I think, this autonomous, but this is totally autonomous. This can't, I mean, I said learn from feedback sometimes. Why? Because they have some memory. Okay, since they have some memory, not absolute memory, they still have some memory on what work you have done previously, or what you have, I mean, on what data you have trained and validated. It holds some memory. So sometimes it can learn from feedbacks. This absolutely learns from agentic AI. Absolutely, it's free to use. It has lot, and it stores lot of data. Okay, like how we have data centers. It can store lots and lots of data. Like in some of these MLs also, they can store limited data for few projects which we are doing, which I'll show. They can store some data, but AI agent can store large data sets. Okay. And coming to the last, I say that as the complexity of the models increases, you will be landing up in risk. Okay. Mainly I'm talking of regulatory risk, because ours is a regulatory industry. If it's not a regulatory industry, you can play with these agents like whatever you want. But unfortunately, fortunately or unfortunately, we are in medical areas. Maybe sometimes I feel unfortunate. Otherwise, we could have used these models, okay, to the length and breadth of it. Regulatory risk is moderate. Of course, they carry risk even LML models, but that's what we said. We need to give explainability, validation, justification, all this stuff, retraining. I'll share a lot of SOPs on this. LLM regulatory risk is high until you give justification to the auditors. Here, agent in medical device regulatory risk is very high, but still you can use in some of the activities. I'll tell you. Okay, I'll go through this core architecture. It has 5 components, core components. One is perception module. It collects inputs or whatever information you give, whether it's in data, text, signals, images, logs. Okay, it takes the data. That is a perception module.
Sir, the
Yeah,
screen is not shared.
really?
Yeah, I can't see the screen.
Just a second. Yeah, sorry. I don't know where it was. Oh, can you see the screen?
Yes, sir.
So from where you miss the screen here? This comparison of AI agents with ML model, LLM AI agent.
Sir.
What? Have you seen, have you heard this with the screen?
Yes, sir. Yes, sir.
Actually, this is very, very important. Like, what are the limitations of some models? What the AI agent, you seem like, yes, 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 it can do everything. But come to the last row, risk is very high. That's the problem. But guys, I'm telling you, there are a lot of ways to overcome the risk. Okay, there are answers, ways, plans, because since it is doing so many things, we should also find way how we can overcome the risk, high risk that has. I mean, that's going to be the order of the day. Like maybe in a year or 6 months, people will say that this is the most adaptable model which can do work autonomously, okay, and replace some of the jobs or some of the workers, maybe unskilled or semi-skilled, because that's a routine work people will be doing. This is also routine work. Of course, high risk, but people come with answers for any problem, okay, and people enjoy having problems because that gives them work. If there are no problems, I mean, we all will be staying idle. So when maybe today I may say very high regulatory risk, maybe after 6 months or 1 year, there will be some model which says that this risk is moderate or very low. So you use AI. Okay. I said the core architecture is data and perception model. You give see perception, you need to take it not in the language of a dictionary. Perception is something it takes as if you feel it feels the data. Of course, it won't feel the data. I'm telling in a more sensitive way of it. It perceives the data. It understands the data. Okay, collects inputs, data, text, signals, images, logs, and decision and reasoning model. Once you give the data in whatever form, okay, it determines what to do next. Again, I told you before, it may use some ML models or it knows what to do, like which model to use. Whether I need to use logistic regression or linear regression or NLP or CVV, it can use any ML model or it can use also LLMs. Okay, for that particular data, what you have provided, since it has perceived the data, it could be in test images XYZ. Okay. The second is decision and reasoning module. Determines what to do next, may use any of the ML models, including LLMs. Third is the action module. So based on the decision or which model it has to use, okay, you have 10 models or more than 10 models placed. It will pick up which model is the best. Or like say I'm doing PMS, I want to do the complaint, segregate the complaints. It may use NLP or it may use, suppose I say that you reply this or to the regulatory body, it can use LLM. Or I say that you classify this data on probability basis. It may use logistic regression. I may use, see, I told you very little about logistic regression and linear regression, which are very most commonly used and very easy to understand. Where you have, okay, a dependent variable X, you may have, generally we do XY scattered or XY graphs, but you can have multiple Y's or multiple variables. Generally, when we do it in Excel, we basically look at only XY. Okay, in a two-dimensional thing. But when you have more variables in the form of y, you have y1, y2, y3, y10. Still, these models, ML models can work on the different variables. Of course, your outcome will be the x. Okay, that's what we call equationals or outcome. Sorry, outcome could be y is equal to mx plus c. You can lot of variables that will be interpreted. Even in logistic regression, you may think them as very simple models. But if I show you how much data they provide, how much interpretation it will provide, you will be shocked. Like, okay, but you need to analyze, understand what it is trying to interpret. Okay, any point in the data, whether there is a correlation, suppose you have a lot of variables, it can work on all these variables and say which are having correlation, which don't have correlation. Okay, and what is the weightage of each of these variables in carrying the risk. Okay, I'll show you. I'm going too fast than what I have in my store. Okay, then there will be actionable module. It executes tasks based on what model. Okay, sends commands, triggers workflows, and update system. This is what I told you. When you have a genetic AI, it not only pursues data, it takes the decisions on what model it has to adopt. Then it has an action module. Okay, action model is what task it has to do. Okay, you do this task, or maybe from clinical or complaint handling, we'll move to another task of using that in maybe in purchase or in stores. Okay, it will do based on the COA, what you got from the raw material. It will give, okay, and the data what you fed on the technical specification you require. Okay, your in-house technical specifications and the COA, the test data what you got from the supplier. It compares. Okay, and it says that it has to be accepted or rejected. And what is the probability? It also takes up other talks. If you are linked it with logistic regression, it may take what is the probability if it is accepted of the failure of the devices. Okay, or it may tell you probability if not failure of the device. Telling like what is the rejection rates of the devices. Okay. Then when you link up the rejection rates with the decision making on what will happen in the PMS, post-marketing, after you complete your QC, post-marketing, you place them, then your decision making is it will form patterns based on the QC data what you have. I think I told you many a times, based on the patterns of data or trend analysis, you can predict lot of issues or complaints. Okay. But again, it depends upon what's the percentage of accuracy. Could be 90% accuracy. If it is 90% accurate, still it worth, okay, using the model. Okay, then overlooking the model, saying that 90% accuracy is not good, then a complaint happening, okay, or a complaint happening in a patient, or a patient having some morbidity or a risk or severity or sometimes fatality or mortality. So I quoted an example, but I'll show you the real world case study. Execute tasks, sends commands. Okay, it commands within the system, it sets commands like this batch has to be rejected or accepted. It takes decisions. Okay, triggers workflow in the sense, suppose your your equipment, it also has a lot of information on the equipment or the machines. If it is out of validation, okay, generally I told like we need to make a QA calendar to understand a lot of things. Okay, yearly what are the QA activities which we need to take up what we call it as a QA calendar. Okay, daily activities, weekly activities, monthly activities, calibrations, validations, internal audits, all this stuff. Generally, a good QA head will prepare a QA calendar for that particular year. Since we are in January, now you prepare a QA calendar, like what all the activities your company is going to take up in QA from January to December, a calendar year, or you may do it in financial year from March. So that is a good strategy which many companies, big MNCs adopt. You can have a regulatory calendar, you can have a QA calendar, a lot of things can. People, auditors appreciate that you have very planned activities that are happening. Okay, when you document something and say this is what we plan next 1 year, people appreciate it. Okay, I mean, here I'm telling triggers workflows, what I'm talking on machine validation. Think that it is some equipment is out of calibration or out of validation, it triggers a workflow saying that this equipment has to be validated. Okay, it is of self-validation, it can validate itself. There are some systems where self-calibration, not validation, self-calibrations can happen. Like in your analytical systems, analytical equipment, it can do self-calibrations or self-validations, like if you are using some columns or HPLC or LVCMS on the noise, signal to noise ratio, number of critical plates, lot of things are done self. So it can trigger workload and update systems. Okay. And as already said, it has a lot of memory. Okay, remembers past actions very much. It has more memory than our human brain. Okay. Tracks context because it understands the context, like our human brain also. It understands when you give some data, understands on in which context this data is provided to me. Okay. Tracks the con. If I give some clinical data, it understands this is a clinical data. I need to do something related to clinical, not something related to validation or QA or RA work. Okay, that's very intelligent. It tracks content and maintains goals. That's saying after you track it, you need to execute some work. So what is the goal after tracking the data? Okay, past data, once you give the data, what the outcome, whether what models should I, again, it will be a looping of the system. What we call it as a feedback loop. Okay. Observers outcomes, adjust future behavior. It can adjust, but I said like still you can have some little bit human intervention in this. Okay, on the feedback loop, or you can stop the loop, say that this is fine. But the problem is like it, you need to start from zero again when you do. So the best thing is to give feedback loop to the same thing. Okay, whether you do manually give the feedback loop or you by default give the feedback loop autonomously, let it do the work continuously. Okay, because it's working through some logic, some intelligence. Okay, and perception of data, classification of data, or on decision making. Okay, has a memory. It can classify tasks, it can understand the context with what you're doing, it can maintain the goals what it wants. So if you, for some works, if you maintain it default work autonomously as a loop, it's good. But you can stop it at a task or terminate it. And manually you may ask later by your interference, looking at the outcomes of the data, you may trigger, do that work again. Okay, there could be little intervention. See, the core principle is, this is what I'm talking. Once it has autonomy with feedback, it becomes very important. And when you have regulations, it becomes risky. Okay, it sends, it decides, it acts Of course, it learns from the data and it keeps repeating. This is what is the basic difference. For some ML models, you need to train them repeatedly. Okay, otherwise there will be data drifting or over drifting, under drifting of the data. But here it learns from the data. Okay, and it can autonomously perform based on the text data what you have fed. So it is more adaptable, efficiency and risk amplification. We can control risk amplification if properly trained and properly managed, have proper governance over it, if controlled. Okay, there are a lot of agents like reactive agents. Just these are the first level of agents. They only react, they don't have memory, low risk, but still can be used, respond to only input and do a particular task. Okay, deliberative agents, they can do something like a middleman. They can plan actions, evaluate goals, options like what workflows should I do. Okay, and they use internal models, like we said, any of the ML model they can give, but they have the risk. Okay, learning agents, these are the one which are very dangerous. Okay, this reactive and deliberative agents are okay. Still, they may not enter into total autonomy. But learning agents, once they keep learning, they do works autonomously, like they do the decisions, they take the actions, they have the goals, and they loop up. Okay. Modify behavior based on feedback. That's what learning, continuous learning. It keeps continuously learning from the outcomes. There is no need of training you, retraining it again and again. It learns. Yeah, that's really wonderful how a system learns. Okay. Of course, higher risk in regulatory environment. But this is because of higher risk. When they trigger actions without review, if they are taken any actions without human review, it may escalate into much more risk or much more problems. Escalate workflows automatically, it can escalate. If there is a one work, I mean, for a particular activity, if we can do the work or particular task, we can achieve the action or goal with one task, okay, with one activity or with one workflow. That is fine. But some of these agents, what is they automatically escalate a lot of workflows. Okay, because they are not sure which one will work. Okay. Because when we use human intelligence, we know which one will work, which some is like it does like a design of experiments. It keeps all variables open, mix of variables, and decides on a lot of workflows. Of course, it arrives at what is the best possible, but still, I mean, escalation of workflows is not good. And it can change, as I said, this is where it's because it is self-learning, it can change the system states, it can automatically change how it is functioning. After say, after 6 months or 7 months, since it keeps self-learning, it changes its system, its decisions keep changing. Okay, it keeps switching on models from one to one, or sometimes it may go to the wrong models, or sometimes it may use a simple what you call uh, a complex model for a simple data. Okay, or vice versa. Like for a complex data, you'll use a simple model where there will be overfitting. Other way, if you use an complex model for simple data, there will be underfitting of the data. So these are some of the issues. And the behavior also will be like erratic, like how you see some people in our departments where they're not sure like how they behave. we can't determine like how their next behavior will be. So sometimes like these systems also work like whether we don't know what decision it's going to take, and we have to look at like so anxiously what decision it has taken or how the workloads are going. It will be like a suspense thriller. Okay, more like Malayalam movies. Too much of suspension will be there. Of course, we can overcome that. This all comes to how you validate. So you need to do a Pakka validation. I always say that explainability is very tough in advanced models. You can't explain some of the things, how it has taken decision, how the workflows came, how it achieved the goals, what is its learning pattern, what it learned. Okay. Some are not visible, some are not explainable. Okay, explaining sequence of agent action is harder. A single model output is difficult. Okay, this is rule-based agent, and this is yeah, this is very relevant now in the geopolitical context. Okay, rule-based in the sense it functions as per the rules, like how India and Europe, or just now we have seen Canada having rule-based order. They're having trade deals rule-based. Okay, but see US, they are not following rule-based system. Rule-based is best a system that can happen. But when it becomes so autonomous that you don't have rules and regulations in any of these on your trade deals, on your defense, on your security, the world will collapse. It will break down. Okay, like what US is doing. Uh, so rule-based agents are what we discussed, ML, all ML models, including LLM. But this agentic AI, agentic are learn and adapt. They learn and become adapted. I was using this word many a times. Like they keep learning and they adapt to the new system. Sometimes it is good. Actually, I do appreciate US what it is doing. Okay, it made all countries to realize what are our weakness and strengths. Okay, now India has suddenly woken up from sleep and try to understand we are not Vishwaguru. Okay, we have some limitations, we have some weakness, and we keep self-boasting every time that we have a civilization, we are so great. But it's not true. Now we are looking at the real world. Okay, behavior is unpredictable, sorry, predictable here. Okay, with this is probabilistic. It may have a probability that it may behave rightly or it may not behave, but mostly you can see the other ML models have predictable. Okay, change is control. You can have a control on the system, on the models. If you want to change control or change the system, you have a control. But this continues because it learns from the feedbacks and okay, uh, it learns and adapts to that. So there will be a continuous changing. Validation is exhaustive. For any ML model, validation is exhaustive. You need to do a lot of validation, but I'll tell you, nothing to worry on validation things. Okay, it's a simple two-step process of validating the models. But if you enter into complex model, it may take 3, 4 steps, but all are possible. Okay, here validation is impossible because again we need to go back. It has its own perception of the inputs. It takes its own decisions. Okay, it picks its own models. Okay, it takes its own actions. It learns on its own. When it is doing a lot of things on its own, how can I validate it? So validation becomes not difficult, not limited. Validation becomes impossible. Okay, governance become code based. It is life cycle based. Code based in a sense it is limited to certain. You give a code or use some input data, it's limited. Okay, it is something like governance is life cycle based until unless you stop the autonomous learning or autonomy of it, it keeps on doing throughout the life cycle of the model. So you need to take a call when to switch off, switch on these or red buttons or green button. So agents require continuous governance, not one-time validation. Examples in medical device, regulatory intelligence monitoring, document classification, complaint raise, support agent, literature surveillance. And basically this you find it in clinicals. You can use this. I'll tell you how can you use in clinical evaluation this. How it adopts AI agent can pick up literature and it itself can do the drafting. Okay. A lot of things it can do. Once you use NLP and LLM, okay, and link it to some sites, it works well. But again, you need to review it. Complaint raise is basically, it gives more inputs like triage is something in advance it provides. Okay, the preliminary information that these things are going to happen. It's good. Okay, that's why I said it's acceptable low risk examples. You don't find much risk here. Okay, if they are providing in advance the preliminary information on the complaints, it's good. And they are also providing a lot of support on literature, searches, compilation of literature, or something and workflows. Suppose if I have a literature, how do I do this? Okay, grading of the literature. I mean, literature search reports, that's what we do. Okay, like the D1, P1, O1, C1, there is some classifications on based on literature which we need to, based on whether it's your device or the predicated device. You give D1 if it's your device, predicator you give D2. What's the clinical outcomes or whether it has statistical outcomes. Okay, a lot of things it can do. Document classification is very simple thing. It classifies a lot of documentation on how you feed it. Like department, it can support departmentalized documentation or something like if you have absolute documents, okay, or the current documents, superseding documents. For us, it may take time to separate the absolute, the current, superseding documents. Okay, but it can read it very fast. It can separate, and mainly if it is a particular department, like what are the QSPs and what are the SPOs? Is the linkage similar? Or the QSP numbers or SPOP numbers are matching? Or revision history? This it can do pretty well. Okay, document classification agent. And regulatory intelligence, it's not only regulatory, any quality intelligence also it can provide. What are the updates that happen? Like last 1 week, what are the updates in regulatory? Obviously, it tells me a couple of things. Okay, if I say only medical device regulatory, it will tell me like that. It will update me daily. It gives me updates like these are the things that were updates. Sometimes you feel irritated, like even some stupid updates also it tells, and then you will delete it. Okay, it happens to me many times. A lot of things I deleted because I got irritated with it. Okay, recommend actions, do not execute safety critical decisions, should operate under human approval. Okay, whatever of low risk, this they should take our recommendations. Okay, not take critical decisions, operate under human approval. These are some which are high risk but problematic, but still you can use them if you have a solution to address a problem or deal with the auditor or pep him up or buttering. Okay, autonomous COPPA. This is what I was talking. Complaint root cause COPPA. This can run autonomously in one workflow or 2, 3 workflows. Classification of complaint, root cause COPPA, verification of COPPA, effectiveness of COPPA, and whether we should report it to the regulatory body. Okay. Risk reclassification also. If you look at risk management, suppose from pure PMS, you'll get a lot of data. PMS includes your customer feedback, complaints, COPPA, all this stuff. Okay, trend analysis, market event, other predicate events data. Okay, that's what we call whether the predicate also are having the same risk and the same complaints you need to check day in, day out. Or yourself are only having those complaints, or you are having new complaints where others are not having, or others are having new complaints where you are not having. Either way, there is some issue. So during that time, you need whatever data you comes, pretty well. All the data of the PMS will become input data to the risk management. Your total PMS will loop back to the risk management file. Then what happens? Your risk classification may change. Okay, those we consider high risk or low risk, that may change. Medium, that heat map may change to green to yellow. Okay, yellow to red, or may drop down from red to yellow to green. Okay, I think you know the colors and the heat map. Okay, it gives a lot of inputs from the PMS, and the reclassification it will change. Okay, self-updating regulatory interpretations. It interprets a lot of regulatory. Like recently, we had change in lot of changes that happen in UAMD are proposed changes. It will give us what are the proposed changes, how you can interpret this, how it is going to affect your organization, the proposed changes. Of course, we have one regulatory quality change wherein USFDA QMS 21 CFR is integrating on February 2nd with ISO. How to do it? Once it is integrated, what will be the effect on your company workflows, all this stuff. A lot of things like you have new biological evaluation, ISO 10993/2025. Okay, what are the changes? There are 10, 15 changes that happen. It will tell you, but but you need to review. And bottom line, don't take them granted. You should have some knowledge on that before you consider them. It can take autonomous change control decisions if there is we have change control documents or change controls like in clause 4 or clause 4.4.2 or 4.4.3. You have control of records and control of documents and control of records. If there is any changes that happens to your documents or reports, you need to raise a change control document. So that this can do when to do this, all this stuff. It's always a validation challenge. I said it's very risky. Governance are required. So some of the examples like post high risk, but still you can use post-marketing surveillance for agents, continuous monitoring, drift detection, behavior, regulatory positioning. Okay, how you position these regulatory agents? Okay, the justification acceptable. Automated agents are used to support information gathering and workflow recommendations. All decisions and actions affecting product quality, safety, or regulatory compliance remain under human control. So what it will be doing is only supporting us, autonomously supporting us, but all decision actions affecting quality, safety, regulatory compliance remain under human control. But we may give this statement, but underneath or backside of the screen, we ask them to do everything autonomously. Okay, I know, like, but for auditors, we give this statement, we have taken it. Okay, these are role of QA and agent governance. Define boundaries. It's not like you can do everything with the agent and replace your whole team and say, I got a agent, I'm replacing all. Okay, you all go back home. Don't do that stupid stuff. Okay, define what it can do, what are the boundaries, how usefully it can be used. Okay, see, thing is, it make it as a supporting system. Okay, not a replace to humans. It can support it and give you more time to do other works. Okay, other works where your intelligence is more important. Okay, but not in decision making or, I mean, absolutely. Though I say that you can do a lot of things, sometimes I support decisions also where it takes much important good decisions. But if the decisions it makes should be consistent and always good. That's what we need to train them, validate them more. These two things are good: validation, training, and validation. Your test once you give test data, you'll have consistency in that. Okay, that's what I said. More of a go how you go on that model and how you. I mean, you need to become experts on this. Like this, I'm not telling you tomorrow you need to deploy. Maybe over 6 months or 1 year. I know AI agents are very difficult to handle. Others you can easily deploy in your systems if there is approval of your management, like linear, logistic, NLP, CD, all this stuff. This you need, this you need, this you can deploy in your personal computer, personal laptop and see what it does. And just keep understanding, just play with it, how it works autonomously. Okay, but not in I mean, real time data or uh, real time content or context where the decisions are very, very important. Okay, but agents still you can use in your personal things for a lot of, not only in QARA, you can feed a lot of data images and see how it works. People started, I mean, uh, people started like with the genetic AI, they started producing some clips, some movies, short, what you call short movies. Some movies also, short movies, there is some whatever. Okay, they started and comes agents versus humans. I already told you accountability, we have a lot of things, but the AI agent doesn't have anything. But they have high adaptability because they learn a lot of data. Okay. See, agentic AI is more linked to agent. It's like when you have more agents combined together for a particular workflow. Okay. Okay, but a workflow and it becomes autonomous and it works like a total system. So, agentic AI refers to agents that are designed to pursue goals autonomously rather than simply respond to information, instruction, or performance isolated work. So, I'll tell you what is the difference between agentic AI and AI agents. So, agentic AI does not execute agentic AI does not execute tasks. It decides what to do next in order to achieve an objective. Okay. AI agent does not just execute tasks. It not only execute tasks, but it also achieves some objectives or goals out of the task, and it goes and it works behind that to achieve the goals. Okay, how to achieve the goals?
Destiny.
Okay, so I've already told the fundamental shift is from tools assistance to autonomous goal driven systems. Agentic AI, as I told, that you have a lot of AI agents, you make come them together. Okay, and what does is like it performs all the tasks. Not only perform the task, it creates the objectives, and it works in such a fashion. It creates you the goals and works in a manner to achieve that goals. Suppose I say my productivity, I want it. It may say your productivity is low, like your yield or something is 90%. And it takes a decision or achieves a goal that this guy needs to have productivity of 95% and makes okay goal of 95%, and it recommends or it outcomes are okay, you make these changes, it may be right or wrong. Make these changes to have okay, our goal is to have high yield. So it makes recommendations or changes or it takes decisions how to achieve that goals. Okay, it may say that you increase that parameter, this parameter, some specifications, you increase the standard deviations. Okay, when obviously when you increase the standard deviations, your rejections will come down. Okay, it may give some interesting observations, some interesting recommendation. So I say like my kappa is this, I have these complaints, how can I reduce? Okay, my goal is to bring down the complaint rate. It provides some information. It's more goal oriented. Okay, it can perform lot of goals because there will be a lot of AA agents linked to it. So you suppose I say kappa, I want to bring down complaint rate. So it looks into all angles of from your supplier to your R&D to all the things. Where is that okay, which is mainly causing these complaints? Okay, and will provide you outcomes of it. What are the suggestions that can be taken up? And sometimes it executes also in an autonomous workflow. It to achieve the goal, okay, it takes up the suggestions and autonomously works on this task. So if you look at this difference, AI agent and agentic AI, the primary role is execute tasks. As I told, it executes tasks and it, of course, it learns, uh, it retrains, it learns. Even agentic AI does this. But here the primary goal is achieve goals. Okay. The primary role of agentic AI is how it can achieve the goal. My goal is so and so. Okay. I want in quality objectives, I want so much. So KPI. It will provide and most of the time it guides you, and most of the times it may change total of your documentation and say that this is how you achieve your KPI, or sometimes you may get less rejection rate and high productivity, or reduce your complaint rate. Okay, it works autonomously. This is being used in lot of systems, I mean lot of other domains. I said like mainly in retail and banking. Okay, agentic AI. are used. Okay, decision scope very local. It is more global. Like it can give you, information in a global perspective because it carries the regulatory intelligence and also the quality intelligence. So it can pick up lot of information from other sources and can provide you suggestions for how to achieve that particular goals. Okay, planning is limited. It is explicit and multi-step. It is explicit in the sense it's inclusive, specific, but it is multi-step. Does the planning. Adoption is reactive. Reactive in the sense it keeps learning from whatever data you provide. Here it is more strategic in the sense because it has access of multiple AI agents. Okay, it strategically chooses which is the best. Right. See, in one AI agent, we told like it is linked to a lot of ML models. But in agentic AI, it linked to a lot of AI agents itself. It is much bigger, like where you see a movie. What is that? I forgot that English movie. Avengers. There are a lot of Avengers, sequel on Avengers. So Avengers, like they are such complicated things. They take decisions. They do everything. They fight themselves. Okay, they are robots, human robots. Uh, Human robotics. They take any form, any shape. Uh, I don't know how many I've seen that Avengers. So it has a very strategic, very intelligent decision making, very strategic. Okay, I hope it adopts. It's not like it adopts very reactively. It looks into all options, okay, and adopts to what is the best strategically that suits that particular context. Again, autonomy is constrained. Of course, I said AI agent, you can control some of this once you switch off the autonomy or you decode the autonomy, but here it is very high autonomy. Okay. In the sense, I said no, it not only execute the task. From the task, it can fix up the goals. And to achieve the goals, it does a lot of other things. Okay. Like you have simply I can put like your QA system, you can keep your QA total QA system under agentic AI. Okay, it will tell you what to do with your production, what do you do with your suppliers, what you do with your design and development, what is under one umbrella, you can agentic. Suppose you have an AI agent specific to R&D, AI agent to supplier, AI agent for something on production, AI agent to QC, AI agent to sterilization. This AI agent all combined will become an agentic AI. So they have workflows. They do have workflows because they are AI agents. Okay, like you can start from they take up the information, any mode of information, any type of information, they take decisions, any models they can pick up, it execute the task, and that continues. And when you have an agentic AI, it also fixes the goals. Okay, what is my goal after executing the task? Okay, you can train it, or you can say that this is my objective or the goal. That goes, it divides them into objectives. Okay, how to achieve the objectives? It works in the pattern. It autonomously works. Okay, picking a lot of information from different AI agents. It will pick up from R&D, this. You may have an agent for your PMS complaint handling. So all this work, like you have a total department there. Okay. Of late, many people are using this. I have just read genetic AI workflows. Mainly, I've seen this, read this in automobiles, like on this, what do you call? EV, electric vehicles, and also self-driving. It's total genetic AI that works. But I have my own doubts when coming to regulatory device. Okay, why this came is we have very complex workflows which genetic AI can do independent tasks, continuous chain, information overloaded. I like this word. When you have information overloaded, okay, we collapse, like we postpone. There's a lot of procrastination, we defer, we change, but this can do pretty well when you have multiple workflows, complex, okay, interdependent tasks, continuous change, because they do work autonomously, unlike us. If humans are there, they may delay or they may question, there and won't be linking of work. You need to plan your work like, okay, guy, you get me this. There will be some, I mean, a lot of what we call subjective or human centric issues. Okay. Of course, to work as a team is always good, but it doesn't sense all this team, whether you're sick or you're tired. It keeps working. Okay. When traditional automation failed because rules break under complexity. Yeah, this is true. When you have complex data, complex system, okay, sometimes we need to break the rules. Okay. Okay. And there is the idiom like sometimes you need to break the rules, and rules are broken for the good. Okay. Of course, we Indians are very good in breaking the rules. So, some we are experts in breaking the rules, and we find lot of ways how to break the rules. So when there is some complexity of data that comes, we break the rules. Okay. But under the boundaries, uh, we should do. That's the problem with traditional automation. But here, without breaking the rules, because this is not rules-based system, agentic AI. Okay, it is more adaptive. Okay, autonomous. It doesn't care about rules. That's why the regulatory compliance is very high. Humans cannot manage everything manually. Static workflows do not adopt. We have a lot of static workflows. Status quo is a lot of works be in status quo. But here, a lot of decision making happens, the workflows happens, goals are fixed, the objectives are fixed, and there is a, uh, loop back system. It keeps working. I really, like this. But I know, I know there is. Okay, agility exists to break complex. This is what I said. If you have complex goals, it makes into sub goals or different objectives. You may have a big goal like I want to be, I want to have like 0% complaint rate, which is impossible. Or I need to have 0% QMS compliance, which is impossible. But still, you can break down how to achieve them into sub goals, into objectives, and look at how agentic AI does it. It may does it in some different fashion, which we may not like, or the regulations may not accept, but still it does something. Just check it out and review whether it's good or stupid. Okay. Decide task sequences dynamically. That's what we call what to do first, what next, what loss. Okay. Sequencing of the tasks for achieving that particular goals. Uh, that we can also do, but for us it takes some time. We need to discuss with the team. Okay. We have a head, we have somebody sitting above the head, you have management, all this much of bureaucratic interference comes. It is sometimes good, but sometimes irritating. So it makes it powerful and dangerous in regulated. See, this sentence is has to be read. This makes it powerful and at the same time dangerous. So if we can work on this word dangerous, how to remove or answer this dangerous or find solutions, okay, to remove this word dangerous. I know people are working on that. A lot of people may come out with some answers how to remove this. The risks, the dangers, the limitations, all this stuff. Then it makes it a very powerful tool. Okay, maybe after a year you remember me when you see agentic AI agents coming in your systems. Okay, mainly for you two guys. Okay, so you are the one I see in whole of AML. You are the ones who will be very near to adopting AML, mainly genetic AI or AI agents. I don't know whether you already adopted. Okay. Of course, Medtronic has adopted. Of late, we see Merrill Life Sciences getting on with surgical robotics and a lot of other systems. So there are 5, 6 good companies who can work on a genetic AIs. Okay, not only regulating the workloads, executing the goals, okay, sub goals, all these tasks. But end of the day, to achieve a very precision based, okay, operations or surgeries, uh, it's better for safety of the patient. Some complex surgeries, where it's not like a simple surgery like appendicitis, you can use surgery, but still it does. Appendicitis also it can do surgical robots. But for more complex surgeries, uh, like on um, brain clots or brain uh, hemorrhages in brain or something linked to uh, surgery that is linked with cancers. Okay, where you need to, I mean, surgically remove precise amount of this malignant cancer mass. Okay, and a lot of other surgeries also. I am foreseeing like this AML or the surgical robotics someday are going to insert, okay, genes into the human cell. Okay, there's high probability that they will do it. Okay, because there are a lot of advantages if you studied the gene therapy and gene manipulation. Okay, there are a lot of advantages mainly in some neuronal diseases. Gene therapy is very costly, but surgical robotics make it very easy. Okay, and why I'm talking is when you adopt certain AI agents or give chance for a genetic AIs to work. Okay, it's the same thing. Here we have seen AI agents plan, act. Okay, but these are goal driven. They have goal and they keep repeating. See, core architecture is they start with goal definition layer. There we seen AI agent with perception layer, like what is the input you have. Okay, defines objectives, explicit or inferred, planning and reasoning similar to that. Okay, like it may use LLMs, planning algorithms, heuristics. I'll tell you what is the heuristics. There are a lot of planning algorithms. Tool and action interface. It too has a memory content, feedback and learning loop. They are risky because loss of determinism in the sense, because I mean basically guys, Though we see these machines doing a lot of stuff, at the end of the day, they don't understand what they are doing. It is totally controlled by maths, algorithms, formulas. Okay, but for us, that is not a big thing. We understand, we need to understand, okay, what's the outcome that we are getting on it. Our domain is not to write algorithms, but we can take help of some data scientists or people who are good in coding. If you want something more to work with agents or modify them. Okay. See, what are all positives may become negatives. Okay. We talked a lot on goals, managing the goals, objectives, all this. There could be some mismanagement of the goals if total system goes wrong. Okay. If it is not properly governed and properly directed with properly instructed, things may go wrong. Okay. And it may lead to systemic risk on even on the risk stratification of this stuff. Okay, agentic LLMs, like better to use LLMs instead of agentic AI. Okay, why we don't use in medical devices? AI conflicts with medical devices is because of all this. You can't validate properly. We need clear accountability in medical devices. We need to be deterministic processes, human decision authority control change. Agentic AI introduces distributed decision making, dynamic behavior, blurred responsibility. See, as on today, I'm talking of all this, but maybe end of 2026, you see, AI agents, agentic AI, people will be talking more on these two things, like how we are today talking on generative AI, like on Grok or Gemini or on ChatGPT or on Llama or Perplexity, a lot of things. Okay. This agentic agents maybe in I don't know how quickly it will come. In 6 months or next 6 to 9 months, they are going to actually control more of the work. Madhu, you don't worry, it won't replace your work because you are still employee, you know what to do. Okay. Uh, but let's see what happens with this agentic AI. I'm fingers crossed, I too don't know. But I'm being an over optimist on AI ML. I see these two things. Okay, already LLM has crept into all fields, all domains. Let's see how this AI agents and agentic AI, of course, I'm 100% sure they will be dominating all the domains. Okay, may not be much in healthcare. Let's see how it works in medical devices. Medical device comes under healthcare. Even a lot of hospitals are using agentic AI in their workflows. Like I've seen one hospital, okay, that's Kim's Hospital in Hyderabad, where I can't call it agentic AI. They have this what they call Health Ray, a software called Health Ray, which does this, which automatically does a lot of tasks. Okay, from billing, writing discharge summaries, so medicines, what medicines has to go to which patients, all that is generated. I see that in hospital management, not in clinical management. Clinical management is something when you do the clinical trials. Of course, there is a software to do the management. Mainly, we call it clinical data management. Okay, how to manage the data. Okay, with a lot of cyber security, all this. But let's wait and see how this goes. Isn't it okay? The regulatory positioning is the same wording everywhere. We use the same. Autonomous systems are used to support information gathering, workflow coordination. All quality, safety, and regulatory decisions remain under direct human control. The unacceptable language is AI manages compliances. You are gone. System ensures regulatory adherence. You are out. Autonomous quality management. You'll have a red flag. So we'll understand what is the role. Once we start practicing using these models, use some data. Maybe next class I'll tell you more on the stepwise process of how to do this for all models. Then from that class we will see, okay, anybody can share or I'll share my system, how I'll download them, how I provide my data to the model input data. If it is in Excel, like it doesn't take Excel, it takes in CSV. I'll tell you what the CSV is. You can easily convert Excel into CSV. If there are, how you need to clean up data. Okay, missing data, duplicated data, a lot of data has to be cleaned. Then how you train this, what are the different, you'll have multiple options. We can start from linear regression. That's easy to understand. What are the things you want to work on? Suppose if I have more dependent variables. Actually, I thought of discussing this today class, giving more y values. Okay, you have x, y, you have y's of more variables, dependent or independent variables. Okay, generally we'll have work on x, y. But if you have more y, y1, y2, y3 data, more data, in the sense, I'm not talking of large data, more variable data. Suppose you have y1 to y12, and the dependent variable is only x, on which we need to calculate a lot of things. Okay, like in classification, I said a logistic regression, or in linear regression, I said x is the probability of getting a heart attack. It gives somewhere between 0 to 1 what is the probability, and it also gives accuracy. So we need to learn more on what the outcomes are, how we interpret the outcome. But I have 10 variables or 15 variables. I take X1, suppose I have 100 patients. I take body weight of them. I take a lot of things like their genomic sequence or LS. I take the smokers, non-smokers, obesity, BMI, all those maybe 15 variables of 100 patients. Okay. And I train it. When I train it, it gives me probabilities, what we call X, the probabilities like who are prone to have heart attack or cardiovascular risk. Again, I'm telling you, I need to use a word. These are all labeled data. Okay, when I say labeled data, I know all these 100 patients had cardiac, some cardiac risk. Okay, that is the ground truth we call. So I collected data from patients who already had cardiac risk of 15 variables like weight, XYZ, body weight, gender, mass, that, this, but should be very relevant to what we are asking. It's not like you get all the data which is irrelevant. That's very stupid way of gathering data. Because as I said, data is very important in AML. So once you get the data, we will determine a lot of things like how one variable is related to other variable. Okay, suppose how body weight is related to cardiac risk, or like how diabetes is linked to cardiac risk. Okay, like how smoking or alcohol is related to cardiac risk. Okay, how age is related. You can get lot of information on this. And of course, we will arrive at a probabilistic probabilities, like if it is a combination of 3 or 4 variables, what is the probability? Suppose I take, it will only tell these are high risk variables. Like I say, obesity and diabetes combination is very deadly. With hypertension, there is high probability. Okay. If you add smokers, but surprisingly, when I done with smokers, I don't know whether the data was good. Smokers doesn't have so much influence on cardiac risk. I mean, smoking doesn't have so much of influence on cardiac risk. I don't know why it can, but to my understanding, smoking should have some effect on cardiac risk. Maybe it has some effect on hypertension, which also is a cardiac risk. So some you'll find some very strange data, same information. But the model what I adopted has gone right. I mean, the accuracy of prediction was something like 83% or 85%. Somewhere that where I use random forest, that's convoluted deep learning. Some maybe during our hands-on experience on these platforms, I'll show that data. I have already published it, but I want to prepare that as an app to democratize as a free app to everybody to check where they are prone to cardiac risk. Because I told you someday that Indians are very prone to cardiac risk in very early stage. In 30s and 35, they are having cardiac risk. By the time it is diagnosed, okay, they'll land up with so many other complications. And India is hub of diabetes. India is a hub of obesity. So India is a hub of a lot of chronic diseases, like 35% of Indians obese, 26 or 28% are diabetic, 30% are hypertensive. So you have all these problems. So we need to find some solutions to detect or diagnose them at early stage. Okay, I'll stop here. Maybe in next session, I'll discuss on the practical way of working on these models with some data. Okay, then you'll have a very good, clear, crystal clear, pragmatic, comprehensive understanding. And I hope you love working on these models. But I know all of you are working professional, you have a very limited time. That's why I said, since you can't buy time, nor you or me or Elon Musk, so we'll see how these AI models can help us, okay, to multiply our, I mean, given time by God. Take care. See you soon. If you have any questions, you can ask me or text to me. Maybe Madhu, I hope I have answered your question. Don't worry about you are a skilled white collar employee. Your job is safe. All of you are
Yes, sir.
skilled. Yeah, all of you are skilled employees. You have a lot. You make. That's why I think I spoke with you. It's one is a question of skill, but at some point, you all guys should fall into the category of taking decisions. Maybe Mother, you check in November. I shared some on your SWOT analysis or something like that. You should grow to a stage where you may take decisions. It's not like you keep documenting whole of your life. Through that experience, you need to grow higher, and the highest point is you need to take a call decision. Sometimes it could be very risky decisions. Okay, not maybe, may not be, not that kind of, could be, could not be. Take decisions like yes or no. Don't be like a maybe guy. Okay. So you need to gain such a logical experience, not just on documentation, logically working on these things and at some point taking decisions and being accountable for taking decisions whether they are right or wrong. Okay. So then you will become indispensable or you will be there. But as long as you keep doing all this manual work on documentation, it's good like you're doing it, but you need to still upgrade your skills, upskilling, a lot of things, interdisciplinary, more adaptive. Okay. Of course, I know you are all working professionals, you are not my students. But since I feel you so close to me, I'm playing all these things. Okay. Any help you need, you let me know. And keep working on, I mean, not on this, you divide your time like how to enhance your okay profile and skills. And don't be too much afraid of this okay artificial emissions. Okay, take care, guys. See you on Wednesday. If you have any doubts, you can text to me on WhatsApp. Okay. Any questions you have?
No,
That's
sir,
correct.
thank you.
Yeah, take care. Bye.